Welcome to another episode of Explained by AI.
Hello.
Today we're diving deep into Bloom filter indexes in DataBricks. This is a really crucial tool, I think, especially for any junior Databricks engineer who's looking to, optimize query performance.
Yeah, absolutely. And get a handle on data skipping.
Exactly. Think of it as, well, a way to seriously speed up your data searches and, importantly, cut down on those processing costs.
Definitely. So let's start with the basics. What is a Bloom filter?
Good question.
At its core, it's what we call a probabilistic data structure. Its main job is to quickly check if an element is possibly in a data set.
Possibly.
Right, possibly present. Or if it's definitely not present. That's the key.
Okay, so it's not always certain if something is there?
Exactly. That's the probabilistic part. It can sometimes give you a false positive. I might say, yeah, maybe it's here even when it's actually not. But and this is critical, it never gives false negatives. If the Bloom filter says, nope, definitely not here, you can absolutely trust that. It's 100% correct on the not present part.
Okay, I think I get that. Like a super fast security checkpoint, but maybe slightly unreliable on the yes side.
That's a pretty good analogy, yeah.
Yeah.
Very fast, but with that small chance of letting something through that shouldn't be, metaphorically speaking.
So how does this fast filter actually work inside Databricks? How does it help with my tables?
Well, when you create a Bloom filter index in DataBricks, say on a particular column,
Like a user ID or something.
perfect example, it essentially creates a very compact summary, like a fingerprint of the data in that column across your data files.
Okay, a summary.
And this summary allows DataBricks, when you run a query with a filter on that column, to quickly check without reading the whole file, is it even possible that the value I'm looking for is in this specific data file?
Oh, I see. So it helps decide which files to even bother looking into.
Precisely. That's the data skipping benefit. It leads to, well, a bunch of good things. Reduced CPU usage because you're processing less data overall.
Makes sense.
Fewer I/O operations that's reading from disk, which can be slow and costly.
Yeah.
And ultimately, that means lower query costs. So, going back to your example, searching for a specific userid in a huge table. The index helps Databricks instantly rule out tons of files that couldn't possibly contain that ID.
Okay, that sounds powerful.
Yeah.
But what's happening under the hood? Technically, how does it build that summary and do the check?
Right. Let's get into the weeds a bit. There are two main technical bits, components.
Okay.
First, you have multiple hash functions. Think of these as mathematical formulas that take an input value like your userid and crunch it down into a number, a hash value. And crucially, you use several different hash functions.
Multiple functions, got it. What's the second part?
The second part is a large bit array. Just imagine a long sequence of zeros and ones actually, but it starts as all zeros.
Like a long string of light switches, all off.
Exactly like that.
Yeah.
So when you add a value to the index, let's say during the indexing process, you take that value, apply all those different hash functions to it. Each hash function gives you a number, which points to a specific position or light switch in your bit array.
Okay.
And you go to those positions, those switches, and you flip them to 1, turn them on.
So multiple switches get flipped on for each value added.
Correct. Now later, when you want to check if a value might be present, say, in your query's where clause, you take the value you're searching for, apply the exact same set of hash functions to it.
Okay, same functions.
This again gives you a set of positions in the bit array. You then look at the bits, the switches, at all of those positions.
Yeah.
If all of the bits at those positions are 1, if all the corresponding switches are on, then the Bloom filter says, maybe it's present.
Maybe. Maybe.
Because those bits might have been set to 1 by other values that happen to hash to the same positions. That's your potential false positive.
Collisions.
Exactly, hash collisions. But if even one of the bits you check is still 0, if even one switch is off, then you know for sure.
What do you know?
You know that the value you're checking cannot possibly be in the set. Because if it had been added, it would have flipped that specific bit to 1.
Right, because that switch would have been turned on when it was added, so if it's off.
It was definitely never added. So
Right.
definitely not present. No false negatives.
Okay, wow. That's actually quite clever. So, practically speaking, how do I, as that junior engineer, actually make one of these in Databricks? Is there, like, SQL syntax for it?
Yep, there absolutely is. It's pretty straightforward.
Yeah.
Let's say you have a delta table called users, and you often query it using the userid column.
Okay, standard scenario.
You'd write something like this: create Bloom filter index, then give it a name, say Bloom userid,
Right.
then on-table users, then 4 columns, and in parentheses, the column name, so user read.
Okay, that seems simple enough. Are there, like, settings or options?
Yes, there are important ones, usually in an options clause. 2 key ones are false positive rate and num items.
False positive rate. That sounds like what we were just talking about.
It is. You tell DataBricks what probability of false positives you're willing to tolerate. Something like 0.01 means you're aiming for a 1% chance.
And lower is better, but I guess there's a trade-off.
Exactly. A lower false positive rate, like 0.01 or 0.001, means the index will be more accurate skipping files, but the index file itself will be larger. It needs a bigger bit array or maybe more hash functions to achieve that lower probability.
Okay, makes sense. And num items.
Num items is your best estimate of the number of unique values you expect in that column, user in this case, within a single data file.
My estimate. Why does DataBricks need that?
It uses that number, along with the false positive rate you want, to figure out the optimal size for that bit array we talked about, and maybe how many hash functions to use. Getting this estimate reasonably accurate helps make the index efficient.
So I need a rough idea of my data's cardinality per file.
Pretty much, yeah. Doesn't have to be perfect, but a good estimate helps.
Okay, so now I know how to build one. But when should I actually use them? And maybe more importantly, when should I not bother?
Great question. Bloom filters really shine for certain types of queries and data. They're fantastic for highly selective queries.
Meaning?
Meaning queries where you're looking for a very small number of specific rows, like where userid, some specific value, or where transaction it in, with just a few IDs.
Okay, point lookups.
Exactly. They also work well on columns that have high cardinality.
Lots of unique values, right?
Right, like user IDs, transaction IDs, maybe email addresses, and they're generally better suited for columns that aren't massive in terms of the size of each individual value, sort of small to medium-sized columns.
So when are they less useful?
They're generally not going to help much and might even add slight overhead for queries that select a large chunk of your data, like where date some date last month. If that filter matches 50% of your table, you're going to read most files anyway.
Okay, broad range scans are out.
Mostly, yeah. Also filtering on low cardinality columns. Think of a gender column with maybe M, F, O, or a country column if you only operate in a few countries.
Why not those?
Because the min-max stats that Delta Lake keeps anyway are usually good enough to figure out if a file might contain M or F. The Bloom filter doesn't add much value, and there's overhead to creating and checking it.
Okay, so avoid low cardinality. Any other don'ts?
Very broad, non-specific searches where you're not filtering much at all. The index just won't get used effectively.
So, quick example.
Yeah.
Looking for one specific order ID. Good.
Very good candidate, yeah.
Filtering for all orders from last Tuesday. Probably not helpful.
Probably not, especially if that was a busy day. Delta's regular data skipping based on date ranges will likely handle that well enough.
Got it. So, let's maybe summarize the pros and cons clearly. What are the big advantages?
Okay, advantages. Number 1, significantly faster queries for those selective searches we talked about. That's the main goal.
Speed, check.
Number 2, lower storage costs compared to maybe some traditional indexing approaches. Bloom filters are generally quite compact.
Contact, okay.
And third, they're tightly integrated with Delta Lake's other optimization features, especially data skipping. It all works together nicely.
Sounds good. What about the downsides, the disadvantages?
Well, as we discussed, you do need to estimate that num items, the number of unique values, getting that wrong can impact efficiency.
Estimation required, right?
Right? Then there's the inherent possibility of false positives. It's usually small if you configure it right, but it means sometimes DataBricks might read a file it technically didn't need to.
Potential for wasted reads, okay.
And finally, while they are compact, the index does take up some extra storage space. It's usually not huge, but it's not zero. You need to store that bit array somewhere for each data file.
Right, adds the bit to storage.
So you weigh those factors. For the right workload, the speed benefits massively outweigh the cons.
You mentioned Delta Lake integration a couple of times. Can you expand on how they work together? Like, what's the sequence?
Sure. So when you run a query on a Delta table, Delta Lake has this process called data skipping. It's trying its best not to read data it doesn't need.
Yeah.
First, it looks at the statistics it automatically keeps for each data file. Things like the minimum and maximum value for each column within that file.
Min-max stats, yeah.
If your query filter is, say, where price 500, and Delta sees a file where the maximum price is only 400, it knows immediately it doesn't need to read that file at all.
Okay, that's the first pass.
That's the first pass. Then, if there's a Bloom filter index on a column used in your filter, like our user at example, Delta uses that as a second, finer grain check for the files that weren't eliminated by the min-max stats.
Ah, so it's an extra layer of filtering.
Exactly. It asks the Bloom filter, okay, file X passed the min-max check, but does it possibly contain this specific user that I'm looking for? If the Bloom filter says definitely not, then that file gets skipped too, even if the min-max stats couldn't rule it out.
So it refines the skipping process further.
Precisely. It allows Delta Lake to skip even more files that don't contain the relevant data. Fewer files read means much faster queries, especially on massive tables.
That interaction makes a lot of sense now. And just to circle back on a term you used earlier, probabilistic. Can you just clarify exactly why it gets that label?
Yeah, definitely. It's called probabilistic because of that inherent chance of false positives we discussed.
Right, that maybe it's there when it isn't.
Exactly. Unlike a traditional database index, which, if it finds an entry, points you definitively to the data's location, a Bloom filter only gives you a probability.
It doesn't guarantee presence, only absence.
You got it. It says, if all bits match, it's probably here. But it can say with certainty, if a bit doesn't match, it's definitely not here.
That reliance on probability, that trade-off of perfect accuracy for speed and space, is why it's termed a probabilistic data structure.
It's a clever trade-off, really.
Yeah.
Efficiency over absolute certainty for the is-present check.
It's a very common and powerful technique in computer science when dealing with large-scale data.
So wrapping this up, if I were to explain the essence of a Bloom filter index and DataBricks to another junior engineer, what's the core takeaway? I'd say the core takeaway is this. Think of it as a super fast initial check or filter.
A first line of defense?
Kind of, yeah. Its main job is to quickly tell DataBricks which data files definitely do not have the data you're searching for, based on your filter conditions.
And it does this without reading the actual file content.
Critically, yes.
Yeah.
It just consults its compact summary, that bit array. By letting DataBricks avoid reading lots of unnecessary files, it saves huge amounts of time, compute resources, and ultimately money, especially when you're querying really big data sets.
It's about avoiding the heavy lifting of reading files whenever possible.
That's the essence of it. Smart data skipping.
Well, hopefully this deep dive has really cleared things up on Bloom filter indexes. They seem like a genuinely powerful tool to have in your DataBricks toolkit, particularly when you're starting out and trying to make queries run faster and cheaper.
Absolutely. Understanding the mechanics, knowing when to use them, when not to,
Yeah.
that definitely levels up your ability to write efficient queries.
And it's just quite a neat example, isn't it? This probabilistic approach using clever data structures to handle the sheer scale of big data challenges.
It really is fascinating stuff.
Do you have any topic that you would like to have explained? Drop it in the comments.